Had there been no exams, I certainly wouldn't have gone to school. Well, not true entirely. Exams, I can tell you, have certainly done me good. The not so good part is that one has to prepare for them. But never mind, we at Topper are doing our best to make your preparations a smooth ride. Hi, I'm Arjun Bhagat and today's exam special is dedicated to 2 units, solid state and solutions. Let's begin with the weightage of both chapters.
Let's begin with the weightage of both chapters. The chapter Solid State carries a weightage of 4 marks and the chapter Solutions carries a weightage of 5 marks out of the total 70 marks. This means Solid State carries 6% and Solution carries 7% of the total marks. The type of questions asked define our preparation and the time allocated to it. So let's take a look at the questions asked from both the chapters. Generally, 1 mark that is very short answer type and 3 marks that is short answer type numericals are asked from Solid State. And short answer type numericals worth 2 to 3 marks are asked from the chapter Solutions.
By now, you must have got a good idea of what to expect in the exam. So now it's time for a short recap, in case some of you don't remember the chapter clearly.
From these chapters, you must have learned packing efficiency, mass percentage, volume percentage, mass by volume percentage, molarity, molality, colligative properties, ideal and non-ideal solutions, Henry's law, graphs showing positive and negative deviation from Rolle's law.
Now I hope you're already through with these topics. Let us now have a look at Knowledge Dip, where we tell you what the examiner is testing you for.
A close analysis would reveal that mostly knowledge-based numerical problems are asked from these chapters. However, sometimes representative questions based on the graphical representation of Rolle's law are also asked from the chapter Solutions.
I hope you're all geared up and are ready to tackle the questions that I have in store for you. One feels sleepier while preparing for exams than on other days. Am I right? Well, I assure you that after this episode, you'll enjoy preparing the chapters Solid State and Solutions. Let's head towards the model question now.
Well, in the model question, you need to give 1 example each for the liquid pairs, showing positive and negative deviation from Rolle's law. Also, give 1 reason each for such deviations. Secondly, you need to solve a numerical that says that a 0.2% aqueous solution of non-volatile solute exerts a vapor pressure of 1.004 bar at 100 degrees Celsius. So, find out that what is the molar mass of the solute. To solve this, you should know that the vapor pressure of pure water at 100 degrees Celsius is 1.013 bar and the molecular mass of water is 18 grams per mole. Lastly, find out that why do we consider osmotic pressure as a colligative property. This knowledge-based average level question appeared in the sample paper of 2005. Its first part is entirely textual. The second part tests one's numerical ability as well as the knowledge and application of right formula. Answer this question carefully and follow each step as shown. A solution of N-hexane and ethanol shows positive deviations from Rolle's law because N-hexane molecules weaken the H bonds between ethanol molecules, which increases its vapor pressure. A solution of acetone and chloroform shows negative deviations from Rolle's law because of the formation of H bonds between acetone and chloroform molecules. According to Rolle's law, P1 minus P1 divided by P1 is equal to X2. For a dilute solution, molecular mass of solute M2 is equal to W2 multiplied by M1 divided by W1 multiplied by P1 naught upon P1 naught minus P1. On substituting the values in the formula, we get the answer 4.06 grams per mole. Osmotic pressure is considered as a colligative property because it depends on number of moles of solute and is independent of its nature.
Learning is important, but so are solving questions. This is because questions not only give you an idea of what can be asked, they also help you recall whatever is learned. So here are some practice questions for you because, as you know, practice makes perfect.
Here comes the first one. An antifreeze solution is prepared from 222.6 grams of ethylene glycol and 200 grams of water. Calculate the molality of the solution. If the density of this be 1.072 grams per milliliter, what will be the molarity of the solution? This question, that carried a weightage of 3 marks, appeared in 2007 exam. And according to us, it is an average level question that tests one's numerical ability. Here comes the answer. Molar mass of ethylene glycol C2H4OH whole twice is equal to 12 multiplied by 2 plus 1 multiplied by 4 plus 16 plus 1 multiplied by 2, that is equal to 62 grams per mole. Given that mass of ethylene glycol or W2 equal to 222.6 grams and mass of water W1 equal to 200 grams, the molality of the solution is equal to W2 into 1000 divided by M2 into W1. This comes out to be 17.95 molal. For the second part, we need to calculate the molarity of the solution, whose density is 1.072 grams per milliliter. The total mass of antifreeze solution is equal to 222.6 plus 200, which is equal to 422.6. Now, the volume of this solution is equal to mass divided by density, that is equal to 394.22 milliliter. We can calculate the molarity of this solution as W2 into 1000 divided by M2 into V. Here V is the volume of the solution that we have calculated in the earlier step. So after calculations, our answer comes out to be 9.11.
A good question touches not one but many areas of the concept targeted, and it's always difficult to brand that question as a knowledge-based one or a conceptual one. Most of us are wary of good questions, but don't worry, when I'm through, I'm sure you would be looking for the good questions from this topic.
A 0.1539 molal aqueous solution of cane sugar, molar mass equal to 342 grams per mole, has a freezing point of 271 Kelvin, while the freezing point of pure water is 273.15 Kelvin. What will be the freezing point of an aqueous solution containing 5 grams of glucose per 100 grams of solution, the molar mass of glucose being 180 grams per mole? This is an average question testing one's numerical ability. If a question like this is asked for 3 marks, here is how you should answer it. Given that molality of cane sugar solution is equal to 0.1539, freezing point of cane sugar solution is equal to 271 Kelvin, and freezing point of pure water is equal to 273.15 Kelvin. From the available data, we come to know that we have to calculate the depression in freezing point of an aqueous solution containing 5 grams of glucose per 100 grams of solution. So first, let us calculate the value of molal depression constant Kf. For 0.1539 molal solution, the depression in freezing point delta Tf is equal to 273.15 minus 271, which is equal to 2.15 Kelvin. We know that delta Tf is directly proportional to molality m of the solution, or delta Tf is equal to Kf into m, where Kf is the molar depression constant. After calculating the value of Kf, we can now calculate the value of depression in freezing point of glucose solution by putting the values in the formula. Delta Tf is equal to Kf into W2 into 1000 divided by molar mass of the solute M into W1. Here W2 is the weight of the solute and W1 is the weight of the solvent. The answer comes out to be 269.27 Kelvin.
A similar numerical could be asked from this topic. Try and answer this on your own. Calculate the temperatures at which a solution of 54 grams of glucose in 250 grams of water will freeze. Kf for water equals 1.86 Kelvin kilogram per mole. Well, it's time to take a short break. I can safely say that you've earned it. But while you're relaxing, I have a small knowledge-based breaking question of average difficulty for you.
Just try to define osmotic pressure. This question is worth a mark. Think about it during the break. Before the break, we asked you to define osmotic pressure. Did you try to define it? Good. But nevertheless, let me give you the foolproof definition of osmotic pressure. Here it comes. Osmotic pressure is defined as extra pressure which must be applied on the solution side to prevent the flow of solvent molecules into the solution through a semi-permeable membrane.
Welcome back. I'm Arjun and you're watching Exam Special. For those of you who've just joined us, we are discussing solid state and solutions today. We did a model question and also some practice questions where we defined Raoult's law, non-ideal solutions. I also recall the molarity and molality, depression of freezing point and osmotic pressure. Before the break, we were in the midst of solving practice questions. So let's continue with the same, and after that we'll tackle a HOTS question and finish with some exam tips. Now pay attention to the third practice question.
You need to give reasons for the following. Why does conductivity of silicon increases when phosphorus is added to it? Why does Schottky defect lower the density of a solid? This is an interesting question. Here goes the answer. Phosphorus is a pentavalent element. When silicon is doped with phosphorus, it occupies some of the positions of silicon. Since it can form 4 covalent bonds with other silicon atoms, the 5th electron being not involved in bonding can delocalize. This increases the conductivity of doped silicon. In Schottky defect, equivalent number of cations and anions leave their crystal lattice, leaving behind holes, so it lowers the density of a solid.
This 2-mark question was asked in the 2007 examination.
Calculate the distance between Na plus and Cl minus ions in NaCl crystal if its density is 2.165 grams per centimeter cube. Molar mass of sodium chloride is equal to 58.5 grams per mole. This question came in 2006 examination. It is an average level query that tests your numerical ability. For 2 marks, here is how you must answer it. The number of atoms present in sodium chloride molecule is 4. The molar mass of sodium chloride is equal to 58.5 grams per mole and its density is equal to 2.165 grams per centimeter cube. As we know that density is equal to the number of atoms in unit cell multiplied by molar mass divided by volume of the unit cell into Avogadro's constant. By putting the given values in the formula, the edge length comes out to be 5.64 into 10 raised to the power minus 8. Now we know that the distance between sodium and chloride ions is equal to half of the edge length. So the answer of this question comes out to be 2.82 into 10 raised to the power minus 8 centimeter. A similar question of 2 marks can be asked for different compounds. For example, cesium chloride crystallizes as a body-centered cubic lattice and has a density of 4.0 grams per centimeter cube. Now, calculate the length of the edge of the unit cell of cesium chloride crystal.
Weren't the practice questions fun? I'm sure they were. Now we are heading to the HOTS question, where HOTS implies high-order thinking skills. It tests your thought process more than anything else. HOTS requires you to be curious by nature, so it's time to think beyond the books because the nature of the board exams is changing for the better. Let's take a look at it.
An element has a body-centered cubic structure with a cell edge of 288 picometer. The density of the element is 7.2 grams per centimeter cube. So what will be the number of atoms present in 208 grams of the element? This numerical involves a clear understanding and knowledge of relationship between the various terms in density formula. In this question, the volume of the unit cell is calculated in picometer. So our first step will be the conversion of this volume into centimeter cube. This comes out to be 2.389 into 10 raised to the power minus 23 centimeter cube. Now we will calculate the volume of 208 grams of the element by dividing the mass by density. The value comes out to be 28.89 centimeter cube. In the third step, we will calculate the number of unit cells by dividing the total volume by the volume of one unit cell. This comes out to be 12.09 into 10 raised to the power 23. For a body-centered cubic structure, number of atoms present per unit cell is equal to 2. So the number of atoms present in 208 grams is equal to number of atoms per unit cell multiplied by number of unit cells. This leads us to the answer, that is 2.418 into 10 raised to the power 24.
Did you get the answer properly? Well, if you have any doubts, log on to our website www.topperlearning.com and get all your queries answered. So instead of better study, score better, the mantra should change to study better, score better. I also have some tips for you which will help you prepare better for these topics.
Numerical ability-based questions are mostly asked from the chapter solutions. So it is important to do the calculations very carefully, as even a slight mistake can reduce your score. Also, recheck the units in the numericals to keep your score up. Sometimes questions based on graphical representation of Rawls' law depicting positive and negative deviations are asked. So while revising, practice the graph on paper. In the questions related to the calculation of edge length, make sure that the number of atoms per unit cell you put is correct according to the structure of the unit cell given in the question.
These topics can be very scoring if you prepare right. So keep your cool during the exams and be careful while solving questions, and you'll surely come out a topper. On this positive note, I'll take your leave for today. I promise to be back with another episode of Exam Special. Good luck and goodbye.